Welcome all of you. This is the second lecture of our first unit in where we will deal with the dot product and cross product of the vectors. Here we will know how to represent the dot product and cross product of the vectors, and also we will be able to study the properties of the dot product and cross product. These are very useful in solving many problems. This concept is useful mainly for problems. Okay. See, we can see the what is meant by dot product. This is used to know the direction of two vectors. Dot product of two vectors means the product of the magnitude of the two vectors. We can observe mod A into mod B and cosine of the angle between the two vectors. So, dot product of two vectors A bar and B bar is given by A bar dot B bar equal to mod A mod B and cosine of the angle between these vectors A and B. So, the scalar component along this dot product is AB cos theta, and the vector component along this dot product is AB cos theta into the unit vector, that is AB. Okay. So, how to express the cross product means, suppose if there are two vectors A bar and B bar in the xy plane, there are two vectors A bar and B bar in the xy plane, this is A and this is B. Now, the cross product of these two vectors A bar and B bar is given by the perpendicular vector. The vector which is perpendicular to this A bar and B bar plane is the cross product. This is the A bar cross B bar vector, and this can be given by the area of the rectangular parallelepiped that is formed by the A and B. See, we can observe here there are two vectors A and B in the xy plane. That means they are kept like this in the xy plane. Now, A bar cross B bar is the vector which is given by in perpendicular direction. Okay, and A bar cross B bar cross product is expressed as the product of the magnitudes of the two vectors with the sign of the angle between them. So, A bar cross B bar is mod A mod B sin theta, and here we should also mention the unit vector. The unit vector along this A bar cross B bar is AN. We can clearly observe that here. Okay. So, this AN is a vector which is perpendicular to the plane having A bar and B bar. So, what are the properties of dot product means? Dot product obeys commutative law. That means A dot B should be equal to B dot A, and dot product also obeys distributive law. That means A dot B plus C should be equal to A dot B plus A dot C, and A dot A should be equal to mod A square. These properties are very useful in further derivations, in the upcoming derivations, and it is clear that if the two vectors A bar and B bar are both perpendicular, then the dot product is simply 0. Okay, because A dot B is given by mod A mod B cos theta. Suppose if the two vectors are perpendicular, then theta is 90 degrees, so A dot B should be 0. Next, if you are taking any scalar k, if you are multiplying the dot product with a scalar k, you can observe that multiplication here. These are the properties of dot product. Okay. We have known what is meant by cross product. That means if there are two vectors A and B in xy plane, the cross product of these two vectors is the vector which is perpendicular to the plane containing A and B. So, the properties of cross product are, cross product will not obey commutative law. That means A cross B is never equal to B cross A. Cross product will not obey commutative law. Cross product is anti-commutative. That means A cross B is equal to minus B cross A. Next, cross product is not associative. Cross product will not obey associative law. A cross B cross C is never equal to A cross B cross C. Next, cross product is, but cross product obeys distributive law. That means A cross B plus C should be equal to A cross B plus A cross C. So, dot and cross product of unit vectors in Cartesian system, it is very clear that if you do the dot product for two similar unit vectors, that means Ax dot Ax, Ay dot Ay and Az dot Az, the dot product of two similar unit vectors is always equal to unity. This is very useful formula in solving problems. The dot product of two similar unit vectors is always unity, that is equal to 1, and the dot product of two different unit vectors is always equal to 0. That means Ax dot Ay, Ay dot Az, all those dot products of two different unit vectors is always equal to 0. Next, cross product of unit vectors is Suppose if you are taking cross product of two different vectors ax cross ay, then that product is equal to the third vector az, and ay cross az is ax and az cross ax is ay. This is about the dot product and cross product of unit vectors in Cartesian system. Next we will see the dot and cross product in cylindrical systems. As we already know that the dot product of two similar unit vectors is always equal to unity. That means a rho dot a rho, a phi dot a phi, two similar cross product, two similar vectors dot product is always equal to 1. But what is the dot product of two different unit vectors means it is always equal to 0. Next we can also see the cross product of two different vectors. We can observe these formulas. If you are using two coordinates here, the result is the next upcoming coordinate. Suppose if you are using xy, the third one will be z. Suppose if you are using rho phi, the third one will be the third coordinate z. This is the dot and cross product of unit vectors in cylindrical system. Next, dot and cross product of unit vectors in spherical system is like this. We already know that the dot product of two similar vectors is always equal to 1. Two different vectors dot product is always equal to 0, and two different vectors cross product is the resultant one is third one. If you take two coordinates here, the resultant is the third coordinate. We can clearly observe that. Next, this is the spherical system. If you want to find the dot product of unit vectors, that means interlinkage. If you want to find the dot product for the unit vectors in Cartesian system and cylindrical system, that means I want to multiply ax. I want to find the dot product of ax with a rho. Like that, if you want to find the dot product for two different coordinate systems, then these are the interlinking formulas. I want to find the dot products for Cartesian system to cylindrical system. These are the interlinking formulas. These are the dot product values for Cartesian and spherical systems. Okay. So from this topic we can understand that the dot product of two vectors is always equal to, suppose if there are two vectors a bar and b bar, the dot product of those two vectors is mod a mod b into cos theta. The cross product of two vectors is given by mod a mod b sin theta multiplied with the unit vector. Next, the dot product of two similar unit vectors is always equal to 1, which we have observed from the previous formulas, and the dot product of two different vectors is always equal to 0. Then what about the cross products? Cross product of two same unit vectors is always equal to 0, and the dot product will exist for different unit vectors, as we have observed from the formulas. Okay. So these are the possible questions from this dot product and cross product concept. We need to solve all of them. Thank you.